situation. The trip switch on this is a little bit different than what we just saw. Either side will trip the emergency device, and in this case, if either side or both sides are tripped, they need to be reset in order to bring the equipment back online. In this case, either one will trip individually. You'll get the flag coming up, and to reset it, it just needs to be put back into place. Okay. The wash press control, here again, there's a local control in the field, which is located on the other side of the unit. Back on the wall is an emergency stop switch, as well as a handoff auto switch for both the grinder as well as the auger itself. Locally at the equipment, you can run the auger or the grinder itself individually. Back at the control panel, it runs as a complete unit. For troubleshooting it here locally, you can run either one individually in hand. When you go to automatic in this location, that transfers control to the control panel itself within the electrical room, and we'll take a look at that in a few minutes. Okay? The screw conveyor, handoff auto switch here in order to run the piece of equipment. Running it in hand, you can operate it locally at any time. If you go to automatic, that then transfers control to the SCADA system, and there is no other control panel for the screw conveyor itself. It goes directly to SCADA. All right? Any questions at this point?
What about the drain that was supposed to be there?
That, I don't know what the status of that is. Right now, there's a blind flange on here. I don't know what the status is at this point. Conveyor lifts the material up and dumps it into the roll-off container, which is right next door. The roll-off containers are identical for both the screenings and the grit. For visual purposes, I'm going to use this set of controls here. This is actually the electrical supply for the grit roll-off container, as well as the controls for the grit roll-off container, but the system is identical on both sides. The electrical cord that's currently mounted on top of the container and has not been tied in as of yet, it gets removed from the placement on top of the container. Then that plug gets inserted in here to provide power to the screw conveyor within the container itself. Very important that needs to be disconnected before you allow the trucker to pull the container out of here. You've got a handoff auto switch here, located locally, so you can run the equipment locally, or you can run it through SCADA. You've got the labels on this have been misplaced. There are some additional labels that will be going on here, indicating that you've got a forward direction on the screw or a reverse direction. In this case, because it's an end-loaded container, the only reason I can see to run this in the reverse direction would be if you've jammed up and you want to free up that jam within the container itself to relieve some of the pressure on the screw. Other than that, this should be running in a forward direction all the time. Okay. While we're here, we've got an emergency stop switch here, which is attached to the conveyor for the grit system, so that if there's a problem with that piece of equipment, you can hit the emergency stop on that. From a equipment standpoint, you've got your hydrogen sulfide as well as lower explosive limit gas monitors. There's a set two devices here in the room. The one that's directly overhead here is the lower explosive limit gas monitor. That will give you a reading here as well as back to SCADA. The hydrogen sulfide, which is a heavier gas that's going to hang near the floor, has the sensor near the floor here. And there are these two here, and there's also two of each of those within the other room, and I'll point those out as well.
Peter, we noticed that the liner is rolled up on it isn't
Yes, that was indicated during the training as an item that needs to be addressed.
Assuming it'll be addressed shortly before startup.
Yes.
And both of them was down here was supposedly worse than this.
I would assume that because it's an issue for one container, it would be an issue for all 6 containers.
Is that screw gonna be running constantly?
At this point in time, the program is set for that screw to run constantly. My understanding that as of yesterday, there's been a directive in order to change the programming to set all of the downstream equipment beyond the collecting, namely the bar screens and the grid collectors, to run on a intermittent basis based on the collection equipment itself. So that is, I don't think that programming has been done yet. The current programming calls for this to run all the time, yes. All right. Other things I can point out in the room while we're in here is the emergency lighting. If you lose utility power, this is a set of battery-operated emergency lights. The battery system is held within the storage room, which is just on the other side of that concrete block wall. There's a set of emergency lights there, here, and on that side of the room as well. So you'll get immediate lighting if you lose utility power. Once the generator comes online through the loss of utility power, then your normal overhead lighting will come back on within time. These take a little bit of time to cool down and then re-spark themselves. In each of the rooms, there are at least one, I believe there's 3 in this room, in the screenings room itself, that have a quartz light associated with them, so you'll get some light coming on immediately, and then after the lights go through a cool down process, they'll spark back up and come back online. The white beacons near the door and on the other side of the room there are the fire alarm indicators. There's also a speaker system associated with that, so you get both a visual as well as an audible alarm in the case of a fire, whether it be a smoke detector or a heat detector. Up near the ceiling, there are several heat detectors. In this case, there's one over each container, so if you do get into a situation where you've got a high heat condition, that will be indicated through your fire detection system. The blue beacons are indication of a gas detection alarm. If you get either hydrogen sulfide or lower explosive limit detection within the building, the 6 units that are provided within the building itself are tied into that alarm system. You'll get a beacon as well as a klaxon, both inside and outside the building. There are three of the beacons on the outside of the building, one near each one of the entrances. So you're alerted to the fact that there may be a situation that you don't want to walk into. In that case, you'd follow your procedures for notifying the whoever it is that's going to be responding to the situation. I would assume you have procedures in place where you would then have a handheld piece of equipment when you come in, go in to troubleshoot what is happening within the building. Let's see, within this room, space heaters are glycol fed. At this point, that system is not online. They are bringing in some temporary heaters, not the one there. They're actually being mounted in doorways to get some temporary heat in the building to back up in the case right now where the glycol system is not online. The controls for the heating within the building are located in this case here. There's a thermostat as well as a disconnect switch for the equipment up at the ceiling. And you'll notice that around the building there are several of the disconnect switches at each one of the units. Overhead door, you've got a electrical disconnect located up on the up near the operator itself in order to provide power to the door. The door itself is controlled through the blue box right near the to the right of each one of the doors. Simple operation to just open and close. That pretty much wraps it up in this room. Okay, in the electrical room in the East Grit, All of the power feed coming into the building comes into the main substation in the center of the building. This is both utility power as well as the generator power. The automatic transfer switchgear is located within this substation itself, so that if we lose utility power, the generator will sense the loss of power, bring the generator on, and transfer that load to the generator. All of the equipment within the building is fed from the MCC panel. There's a breaker for all of the major pieces of equipment. Some of the instrumentation and lighting and such is fed off of the electrical panel on the other side of the room, and I'll show you that as we travel around. But in this case, what we're looking at is the breakers for all of the major pieces of equipment within the building, within the process operation. Okay, further on down the way here, these are the low-speed switches for the conveyor systems, both the belt conveyors for the screenings and the grit, as well as the screw conveyor for the screenings coming off of the wash press. These are the control boxes for the switches, which will be giving you a signal if in fact you bring a piece of equipment online, a conveyor system, and it does not start for some reason, or if it goes offline during operation, it will give you an indication that the equipment has stopped operating. Beyond that are the two panels here are the alarm panels. It's a power supply panel which feeds to the alarm panel for the gas detection system. There are the detectors throughout the building, as well as outside of the building on the aerated grit channels. The ones within the building themselves are fed back to this panel, so if you do have a high explosive level within the building or a high hydrogen sulfide level, that indication will come back to this panel. Within the panel itself, it's a 3-zone panel. It's indicated on the front panel as to which sensors are being fed to each one of the zones. Here you have the capability, if you do go into an alarm condition, you can silence the panel with the panel silence button. That will shut off the horn here that's indicating an alarm condition. The reset button will reset the panel if in fact the alarm was a true alarm, and the device will go back into alarm and give you another alarm signal. If the alarm had been an extraneous alarm, hitting the reset will then reset the panel and put it back into operation. We do have the capability of using the disable buttons in order to disable a particular circuit, depending on which sensor is gone into alarm. Here you will not get an indication as to which sensor is in alarm. That would have to be viewed through SCADA. There's a constant feedback to the SCADA system, giving you the level of each one of the detectors. So by going to the SCADA screen, you can determine which one is into alarm, and at that point work by disabling the circuit if you need to shut it down. Going further around the room here, we've got the VFDs for the blowers. These are for the grit chamber blowers. 1 VFD per blower. They can be run in either the hand, being the local operation here, where you can adjust the speed using the keypad, or if you go to automatic, then that sends that signal, that control for the blower, to the SCADA system. So the operator can then adjust the speed of the blower through the SCADA system. When the system is on, you've got a control power lamp on. If the system goes into a fault, you'll get a dry fault alarm, and you also have a disable button or an emergency stop button for the system. The blowers are located in the room next door. For filming purposes, I'm not going to go in there just because of the amount of noise that's generated by the blowers. On the control panel for the blowers, you have an indication of the differential pressure across the inlet filter, as well as the discharge pressure of the blower and the discharge temperature. those signals are being fed to SCADA for alarming purposes. Okay, beyond that is the fire alarm control panel, which is sensing problems within the building. There are smoke sensors and heat detectors throughout the building. Those signals will be fed back to this panel for enunciation of a problem within the building. Beyond this panel is the screenings wash press control panel. Here again, you've got a disconnect for the system, on-off auto indications, determining the mode of operation for the equipment, local remote, meaning that the control, if it's in the local position, is here at this panel. You can control it through the on-off auto selector switches, and if this is placed in the remote position, then that transfers control of the equipment to SCADA so it can be started and stopped automatically from any one of the operator control panels. You've got a keypad on the top part of the panel itself, which is used to input information into the system, things like the timing sequence for the forward and reverse cycling of the auger, as well as the grinder itself. Beyond that panel is the bar screen control panel. There's one for each bar screen. You have local control of the equipment from this location. If your hand switch in the field is set to the automatic mode, then you can start and stop the equipment from this location. If in fact that is set in the automatic mode and the hand switch here is set to auto, then that transfers control to the SCADA system. Within the panel itself, these are the timers used to control the bar screen locally. There's the off timer, which is currently set for 10 minutes, and the on timer, which is currently set for 5 minutes, will actually operate the screen on a time basis. The Emitron switch here is used to alert the operator as to whether there's an underload or an overload condition. The equipment itself does not have a shear pin on it. It's using the Emitron switch. These have been set for 70% of capacity of the motor, so that if the motor load exceeds that, the Emitron switch will shut the system down and you'll get a notification through SCADA that has occurred. If the drive chain is broken and the unit senses an underload condition, which I believe is set at 5 or 10% of the capacity of the motor, then that will be indicated through SCADA so that you have an indication that your equipment is no longer running, that there's a problem with your equipment, which would require operator attention. From here, we move on to the card reader control panels. These are set up for will be set up for the septage system. At this point, these are not ready to go, but the control for that system, for the automatic valves on the septage receiving system, are located within the two panels here. And these are the electrical panels feeding the circuitry, the circuits. At this point, they're all locked, feeding the various pieces of instrumentation, the lighting, the wall outlets, etc. You get the electrical panels here. And then over on this side of the aisle, we've got an operator interface panel so that you can access the system. You need to input your username and your password by using the touch screen. If you just click on the username, you can enter the information for your username, then hit the enter button, then go and enter your password, hit the enter button, and then hit the OK. And if you've entered the information correctly, it will allow you to enter into the system and view what's occurring through SCADA. Over to my right here is the automatic transfer switchgear, which again is sensing the power supply coming in through the main utility. If in fact this equipment senses a power loss, namely a power outage in the area from the utility system. Then the transfer gear will send a signal to the generator to start the generator. Once the generator is up and running and up to speed, then the transfer gear will switch the load from the utility breaker over to the generator breaker and put the process back online. In the far corner here, there are a couple of electrical transformers for the electrical supply system, and then the automatic temperature control system control panel is located in the corner. Overhead is the intake air system. That's part of the automatic temperature control HVAC system, feeding both warm or air-conditioned air into this room to protect the equipment. I think that about sums it up within this room. Any questions? Continue a little bit on the support systems within the building. Again, up at the ceiling, you've got heat detectors. There are, I believe, 6 of them within this room. So if you get into a situation here where you've got a fire situation, you will get an alarm at the fire alarm control panel, which is also fed back to SCADA, and I believe that's monitored off-site as well to the fire department. Gas detection system. Located on this wall, there is a combustible gas meter that's sensing the gases at the upper portion of the building. On the opposite wall is another lower explosive limit gas detector, and then on the north and south walls there are the hydrogen sulfide meters. Any of these 4 or the 2 that are in the room next door will give you an alarm indicating that you've got a gas situation. Either at this point you will not know whether it's a hydrogen sulfide or a lower explosive limit. Those values can be monitored through SCADA, so you can determine which gas you're dealing with and which probe is in question. But you will get an alarm indicating that you've got a problem in the building. Again, you've got a blue beacon in here as well as a horn indicating that you've got a situation within the building itself. HVAC systems at this point, I do not believe they are operational. You've got a unit over each one of the doorways, which is feeding fresh air into the building. That's heated air to prevent the building from getting cold. Again, we've got some temporary heat being installed at this point in order to provide heat to the building. On the far side of the building, there are some overhead ducts as well as a piece of ductwork here which feeds below the enclosed channel to remove the odorous air from both the building as well as the channel itself. This will be eventually be taken off to your biofilter, which construction has not even been started yet. There are some fans being installed on the ductwork to supplement that air withdrawal during startup. The blowers have been sized to provide greater air exchanges than are necessary within the building in order to keep the air as required. Okay. On the downstream, once the wastewater passes through the bar screens, it's fed through a common channel and fed into the aerated grit chambers. We'll take a look at that next. There's a valve located on either side for either one of the chambers that's used to fill the chambers. It's an 8 or a 10-inch line. I'm not sure of the size of it. This valve can then be opened to allow the wastewater to fill the aerated grit chamber. A question came up earlier about how full should we put these tanks before we open up the gate. I would say you'd want to have 4, 5, 6 feet of water over the top of the collector before you open your sluice gate, so you don't tend to jar the collection mechanism by dropping the water into an empty tank. The collection mechanism